Okay, we'll get started. So this Kahoot has all the topics in it. Okay, convert 1B8 in base 16 to base 10. Okay, so 4 of you got it right. The correct answer for this one is 440. So if we want to convert 1B8 to from base 16 to base 10, we can write out each digit and multiply it by a power of 16. So we have 1B8 in base 16. So we can, so this is the same thing as 1 times 16 squared plus, so B is the same thing as 11. 11 times 16 to the power of 1 plus 8 times 16 to the power of 0. And if you evaluate that, you should get 440. So that is the answer for this question. Remember, since base 16 has 16 digits, we use letters A through F to represent 10, 11, 12, 13, 14, 15, and 15. Okay, next question. Okay. The year 2024 is 3750 in base 8. How many octal years is it until the year 5102?
Wait, so 5102 is octal, right?
Yes. Okay, so this problem seemed a bit more tricky than the last one, so I will talk about it. So basically, what it's asking is we want to subtract 3750 from 5102 in octal. So we are dealing with subtraction in base 8, which is slightly different from subtraction in base 10. So for the rightmost digit, we just have 2 minus 0 is 2. It's going to be the same as in base 10 if as long as there's no carryover. But for the next one, we have 0 minus 5. So we do need to carry over in this case. And since we're in base 8, we have to add 8 instead of 10. So this is the same as 8 plus 0 minus 5. So this digit will give you 3. And so since we carried over, this digit right here is no longer a 1, it's going to be a 0. So for the second digit from the left, we are actually doing 0 minus 7. And same thing, we have to carry over. So this digit is no longer a 5, it's a 4. This one is 0, okay. So we have to add 8. So 8 plus 0 minus 7 is, so this digit gives us 1. And lastly, we have 4 minus 3 and the leftmost digit, which is just 1. So basically, the result is 1132, and that is the answer. If you found the subtraction to be a bit challenging, another way you could do it is convert. So 2024 is already given, so you can convert 5102 to base 10. If you are to do it that way, this is the same thing as 2626 in base 10. And then you could just do 2626 minus 2024. This is in base 10, which gives you 602. And then convert 602 to base 8, since the answer is asking how many octal years. So this is the same thing as 1132 base 8. So you will still get the same answer, which is 1132. Does anyone have any questions? You'll see more subtraction problems in different bases for the questions that are coming up. You can choose to do it either way. So I think if you subtract it directly in base 8, it's faster, but you have to be very careful with the carryovers. Okay, next question. Okay, so the answer for this one was 6AB. Seems like most of you got it right. But I'll go over the subtraction. Um, I won't convert to base 10 this time. That should be pretty easy. So once again, we are dealing with subtraction in a different base. This time it's base 16 instead of base 8. So we'll start from the rightmost digit like we do in base 10. And in this case, 4 minus 9, we have to carry over. So we will add 16 to the digit. So 16 plus 4 minus 9, which is 11. And this corresponds to B since it's in base 16. And then, so we used up this digit, so it now becomes 1. So we do 1 minus 7. Same thing, we have to carry over. And we just add 16, which is 10, and this is A. So now 0, if we subtract from that, it basically becomes F. And then this becomes 1. So when we do F minus 9, remember F is the same thing as 15. So this is 15 minus 9, which is 6. And lastly, 1 minus 1 is 0. And that's just a placeholder digit. So the answer is 6AB. And oh, interesting. I think it wanted to ask what the value is in base 8, but then I think, okay, we'll just leave it like that then. Okay. So we're given 5 numbers. Seems like they're all in base 16. Which one has the most odd numbers in its octal equivalent? So we have to convert to base 8. Okay, so the answer for this one was 2EF, and I'll quickly go over how you do this one. So the easiest way to convert from base 16 to base 8 is to go from base 16 to base 2, binary, and then go from base 2 to base 8. So every base 16 digit corresponds to 4 binary digits. So B is the same thing as 11, and 11 is 1011 in base 2. 8 is the same thing as 1000, and 7 is the same thing as 111. So 78B is the same thing as 11110001011 in base 2. And then to convert this from base 2 to base 8, we will regroup it into groups of 3. So 011 is same thing as 3. 001 is the same thing as 1. And then 110 is the same thing as 6. And 11 in the front is the same thing as 3. Okay, so the first one, how many odds does it have? It has 3 odd numbers. Okay, so for the next one, I'll just speed through it. And if we group it, we get 5, 3, 1, 6. This has 2 odds. This one is also has 3 odds. And we're looking for the one with the most odd numbers. Okay. Okay, this is not aligned, but anyways, the next one is 1357, and the last one is 5655. So this one has 4 odds, this one has 3 odds. So 2EF has the most odd numbers.
Wait, why don't you just like for every single 3 bytes, just check just check the first one because that's the one with the number of ones. Everything else is a multiple of 2.
Sorry, I'm not sure I understand.
So like, for 3 bytes, first one is just the ones place. So you can just check if it's a 1 because if it's a 1, then that'll be an odd number or else it'll be even.
Yeah, you can also do it like that. I'm just expanding it. I'm just converting it to base 2 and then converting it to base 8. Yeah, someone can't join the Kahoot. Have you tried entering the game pin? Oh, okay. Um, let me see if I can turn on late joining. Um, it's processing your nickname. I don't know what's going on. Okay, yeah, try again and see if it works. Okay, double points. This one is about Fibonacci sequence and also basis number systems.
So what does it mean what is the next number to have 0?
So the first number to have 0 is obviously 0, so that would be too easy. So the question is asking, what is the next number after 0 that has a 0 in it when converted to base 16?
Oh, okay, thanks.
Yeah. Okay, so the answer for this one was 144. So basically, how you approach this is you can convert the numbers of the Fibonacci sequence to base 16. So from 0 to 8, they're all the same in base 16, and 0 doesn't count. We're looking for the next number to have a 0 in its hexadecimal form. So 13 is D. 21, you can basically do reverse division. It's the same thing as 1, 5 in base 16. And then same thing, this is 22, this is 37. So we still don't see a 0. 89 is the same thing as 59 in base 16. And 144 is 90. So this is the next number that has a 0 in it. So the answer is 144. Will there be any questions for elementary school? So this is still a number system question, so you could possibly see something similar for elementary division. Next question. Find the answer for the following recursive function. So this one was 22. Let me see. Let me show the question again. Okay, so F18, since 18 is greater than 10, we're going to use the first equation here, expression here. So it's f of x minus 3, so 18 minus 3 is 15, f of 15 plus 1. So we don't know what f of 15 is, so we have to find f of 15. 15 is still greater than 10, so this is f of 12, since 12 is 15 minus 3 plus 1. We don't know f of 12, so we should find f of 12 first. And we're still using the first expression here until we get to f of 9. Since 9 is between 5 and 10, we should use the second expression. So this calls for x minus 2, so that's 7. Minus 3. And we don't know f of 7, so let's calculate that. F of 7 is still between 5 and 10. So f of 5, which is 7 minus 2 minus 3. And then we need to find f of 5. So since 5 is less than or equal to 5, this is just 5 squared, which is 25. So now we can go back and fill in what we don't know. So now that we know f of 5, 25 minus 3 is 22. So f of 7 is 22, and therefore f of 9 is 19. F of 12 is 19 plus 1, which is 20. F of 15 is 20 plus 1, which is 21. And f of 18 is 21 plus 1, which is 22. So the answer is 22. Okay, Dylan is in the lead. Question 7, find the answer for the following recursive function. But this time we have a pair of inputs. So this question was similar to the last one. It's recursion, which I don't think is in elementary, right? But if you're in elementary, it's still good to know this because this is used both in math and computer science competitions. So let me see the function here. So we want to find f of 12 comma 21. And so for the first one, 12 is less than 21. So we should use the second expression. Okay, so plus 1. And now we should find f of 20 comma 14. And okay, so 20 is greater than 14. So here we should use the first one. F of 19, 16 minus 3. This is, so 19 is greater than 16. So f of 18 minus 3. And then if x and y are equal, then we just output x, which is the same as y anyways. So f of 18 comma 18 is just 18. So this would be 18 minus 3, which is 15. This would be 15 minus 3, which is 12. And f of 12 comma 21 would be 12 plus 1, which is 13. So the answer is 13. This is another recursion question.
You're muted.
Oops, sorry. Um, okay, so you guys didn't hear any of that. So basically, since 24 and 23 are sort of big, and it's going to take quite a while if we were to go down to the base case, which is f of 2 and f of 4. So we start from the base case and then go all the way back up. And you'll notice the results are always in cycles of 6, 2, 4, 4, 2, 1, 1, and then it starts repeating. And we want to find f of 24 and f of 23. So 24, f of 24 is the same as f of 6. So f of 24 is 1. Yeah, so f of 24 is 1. And then f of 23 is also 1. So therefore, 2 times 1 over 1 is just 2. So that's the answer. Okay, Dylan is still in the lead. And double points. I was muted again. So most of you got this one right, which is very good. So f of 9, since 9 is a multiple of 3 and not a multiple of 4, we use the second expression, which is f of 10 minus 1. And since 10 is neither a multiple of 3 or 4, it's just 10 minus 3, which is 7. So 7 minus 1 is 6. And then now we have to do composite functions. So f of 9 is the same thing as, so we can substitute f of 9 with f of 6, with 6, sorry, since we already know what f of 9 is. So it's just f of 6. Since 6 is a multiple of 3 and not a multiple of 4, we still use the second expression. And since 7 is neither a multiple of, so f of 7 is just 7 minus 3 minus 1. So this is 3. And then f of 9, which is what we are looking for. We know f of 9, this whole thing inside is 3. So what we're really looking for is just f of 3. 3 is a multiple of 3 and not a multiple of 4. So we're still using the second expression. And 4 is a multiple of 4, but not a multiple of 3. So there. F of 2 plus 2 minus 1 at the end. Yeah, minus 1. And this is 2 minus 3 plus 2 minus 1, which is 0. So the answer is 0. Dylan is still in the lead, followed by Dan L. Okay, double points and last question, also a recursive question. So, ooh, this one was tricky. So this one you have to be careful because in the second expression, it's actually y minus 1, comma, x plus 1. So maybe some of you switch the x and y's. So that's why for this one, since 3 is less than 18, it's actually going to be 18 minus 1, which is 17 first, and then 3 plus 1, which is 4 second. So it's 17 comma 4. So f of 15 comma 17 is f of 13 comma 10 plus 3. And then these problems are usually sort of tedious. F of 11 comma 13 plus 3. And the base case is x equals y. So we have to keep going until x and y are equal. So, okay, we finally arrived at f of 12 comma 12, which is xy, so this is 144. And then going back up, 144 minus 5 is 139. 139 plus 3 is 142. Wait, I think I made a mistake somewhere. 139, 142. This is 145, 148, and 143. So the answer is, or is it 144? Wait. I think the right answer should be 143, right? Oh, okay. Someone said, I think when I made the Kahoot, I might have accidentally selected 144 as the right answer, but okay. I'm sorry about that. If you got into a loop, you might have made a careless mistake somewhere or could have reversed X and Y somewhere. So be careful with your calculations, but I'm pretty sure this one is 143. So um, so Isabel is our winner. I'm sorry if that mistake messed you up, but yeah, I hope all of you found today's lesson to be helpful, and I wish you all good luck on the first ACSL contest, and happy holidays and happy new year. Thank you all for coming today.
Thank you. Merry Christmas.
Merry Christmas to you too.
Happy New Year.
Happy New Year. Happy holidays, everyone.